You probably already know about real numbers, the everyday numbers that we use to count or quantify things. You may have also heard of complex numbers, which are comprised of a real part and an imaginary part. But what if we went further? Well, two parts of complex numbers can be thought of as a real number times a real unit, 1, and a real number times the imaginary unit, I. From this, real numbers can also be thought of as a real number times a real unit, 1. Extending this, we can arrive at hypercomplex numbers, which have more than one imaginary unit. To visualize this, let's look at an example for quaternions. These are similar to complex numbers but have three imaginary parts with three imaginary units, I, j, and k, as well as a real part. How are these defined? For complex numbers, the imaginary unit I is defined to be the square root of -1, thus the imaginary units of quaternions also square to -1. In addition, the product of all three is also equal to -1. From this, we can find the rest of the multiplication rules. We can also see from this that the quaternions are not commutative, however they are associative. Some hypercomplex numbers can also be expressed as clear algebras, which allows more hypercomplex numbers like the split quaternions to be defined. Clear algebras are all associative, but not all are division algebras, meaning that division by non-zero numbers is not always possible, which makes computation difficult. Hypercomplex systems can also be defined via Cayley-Dickson construction, which essentially generates systems with twice the number of units from pairs of a number system. Using complex numbers for that results in quaternions. Using quaternions results in octonions, which have 8 units, and so on. Why does this matter? Similar to how complex numbers can model points and rotation in a 2D plane, hypercomplex numbers can be used to model points and rotation in higher dimensional spaces, which has applications in computer science, physics, and engineering. They can also be used as an easier to calculate alternative to matrices.